Hello, everyone, and thank you for joining us today. I'm Harry Urban, publisher of Woodworking Network, and I welcome you to our webinar titled Multi-Axis Machining, Transforming Part Manufacturing. Today's webinar is sponsored by CIM-TECH. I'm joined today by Kenny Belfato, CIM-TECH's National Sales Manager, and Giovanni Ramos, Sales Engineer for CIM-TECH. Say hello, gentlemen.
Hello, everybody.
Happy Wednesday.
This will be a very interactive presentation in that there are 3 polling questions in today's webinar. We also encourage you to ask questions and take advantage of the knowledge base that Kenny and Giovanni have in this field. Also, there are 2 handouts available for you to download. One is of the PowerPoint itself that Kenny and Giovanni will be presenting, and the other one is a CIM-TECH brochure. And finally, this webinar will be recorded and will be available within 24 hours. So with that, I'll turn it over to Kenny Belfato.
Thank you, Harry. All right. Hello, everybody. Today, we're going to talk about the multi-axis machining. And I think you may see some surprising information about multiple axis on a CNC router and how this applies, how multiple axis machining applies to woodworking in general. Here at CIM-TECH, we make a CAD/CAM software and a family of different products. And we were founded in 1986 on the idea that your machine is really only as good as your ability to program it. And we really want to bridge the gap between computer-aided design and computer-aided manufacturing and create computer integrated manufacturing. And that's our first name there. CIM is computer integrated manufacturing, so that we can use the CAD and the CAM together in one place. All right, so today's discussion, we're going to talk about how we go from different technologies throughout time, where we had started with 2.5 or 2 and 2.5 axis machining. That was really the beginning of CNC, where you had, for example, just a laser or a plasma torch, where the machine just moves an X and Y and the laser beam turns on and off, or a torch turns on and off. Then we can move into more complicated 3-axis machining, which a lot of times is used for carving on a router, wood carvings. And then 4-axis, which a lot of times in woodworking is considered use of a aggregate tool. And the aggregate can take your vertical spindle and turn it into a horizontal operation, or even a saw or a molder head. There's all different types of aggregates. And then we'll talk more about the new module from CIM-TECH called the 5-axis machining module, and show you how you can program all 5 axes on a CNC router to do very complicated parts. And then how we can use the router sim features that we have now to integrate both 2, 3, 4, and 5 axis together, because you'll see that even though you have some 5-axis machining, you may have to start with some 2.5 or 3-axis machining before you go and do the complicated 5-axis toolpaths. After we present this, we'll have a question and answers opportunity as well.
All right, and before Kenny gets into all of that, we do have our first survey question for everyone. Are you currently using multi-axis programming and machining in your shop? Yes, 2-axis, yes, 3-axis, yes, 4-axis, yes, 5-axis, or not currently. And so we'll give everyone just a moment to put their answers in. And let's see what everyone put in. All right, so it looks like we have a huge majority in 3-axis, so this should be a very interesting presentation. Take it away, Kenny.
Okay, so let's talk about this little icon here in the lower right. You may remember from high school geometry class. You have, most routers have this 3-axis on there. So it's X, a Y, and a Z. And on many machines, X is the longer axis. So not always, but most of the time, X is the longer axis on your router. And then you've got the Y and the Z goes up and down. And so you'll find that the majority of panel processing parts is really this 2.5 axis type of machining where you're drilling holes in the panel, you're routing slots and pockets and dados and profiles on the outside. You're really going to just be moving in X and Y, and then Z goes up and down to enter the material. So that's the majority of the machining for panel processing is this 2.5 axis. And, you know, the little hand symbol here just shows those three, but then we're going to see how you can have the 4 and 5 axis as well, and even more than 5 axis. So there's just a little a simulator there that's showing a tool moving in X and Y, and it goes down in Z to go from one hole to the next or one pocket to the next. This is typical of the 2.5 axis type of machining, where you're just routing, lifting up, moving over, routing, lifting up, moving over. That, again, panel processing, almost all of it is this way. And you've got some pictures of some different 2.5 axis type of machining where you're cutting some cabinetry, and there's rabbets and holes and pockets and grooves in this material, and then some MDF doors where the tool stays down, perhaps, and cuts between the doors. And the profile is a 2-axis profile. Although if you get square corners in these corners here, you can have the tool ramp up and down in the corner to do what's actually a 3-axis move to create a square corner operation. And that term 2 or 2.5 axis could be deceiving because we like to tell people to ramp your tool into the material, and that's really an X, Y, and Z at the same time type of motion. That's a better way to enter your material instead of just plunging the tool in there, which can put a big load on your spindle bearings. It can burn up the bottom of the tool. And these pictures here, these slides are the different types of router sim operations that you could do. And this one is showing a helical motion where it is ramping down in X, Y, and Z. And you can tell that's going to be much better for your tool life right there. So even though it's called 2.5, that's really a 3-axis move. Then we look at some 3D machining or 3-axis machining. Sometimes they call it 3D machining. It's really 3-axis, and this could be the X, Y, and the Z moving all at the same time. Now, in the little simulation you see there, it's really not 3-axis. It's moving in Y and Z and then stepping over in X, and Y and Z are simultaneous, and then X moves over. So if we had set the slice angle on this to a 45-degree angle, then I would get every motion would be X, Y, and Z at the same time. And sometimes, so you can see as this is carving, it leaves these bumps on the part, right? Because it's a ball mill. You use a ball mill to get a finished surface or finished machining on the part. And the closer together you set the spacing, the finer the finishes on the part. And if I were to go on a 45-degree angle, then I can go back on a 135 degree, just the opposite, and I could have like a crosshatch pattern across the part. And that's another way to give you a very smooth surface finish. And here's a little video showing the tool. You can see it moving up, and it's doing that Y and Z simultaneously. And because it's a ball mill, you do have this thing called the cusp height, or sometimes it's called the scallop height. And so the closer together your step over is, the smaller that scallop or cusp height is, and the smoother the part is, and you don't need to sand it as much. So you could see how long it could take to process these types of parts. There's a certain amount of time that's required, and you could either spend more time routing with a close together step over, or more time sanding with a further apart step over, and then you'll have to sand those scallops down. There's a feature in the router sim 3-axis machining called constant scallop height, and it will vary the spacing automatically to get you this uniform surface finish. So as it goes to like a nearly vertical wall, the toolpath has to get closer together to give you that same scallop height as it does across a flat surface. So a lot of times with 3-axis machining, we're talking about carving. And a lot of people get excited when they see a really cool sign or some kind of carved image. They get excited to think that their router could do that. But then when they go to cut that and it takes an hour or 2 hours, now it's not so exciting because you're probably not going to make that much money on that compared to in an hour being able to run 4, 5, 6 sheets of nested parts, right, in a 2.5-axis manner. So the 3-axis machining, it does look cool, but it takes time on your machine to make a finished product. Here's another survey question.
All right, Kenny, thanks for taking that time to go through those. So we'll go ahead and load up this next survey question for everyone. Do you currently use aggregates in your machining? Yes, no, or no, but would like to. So we'll give everyone just a moment to put in those answers. All right, so let's take a look. Oh, it's a pretty even split. It's pretty interesting. So Kenny, we're gonna have you go ahead and tell us about aggregates.
All right, so after the 3-axis machining, we could talk now about 4-axis machining. And on woodworking machines, the CNC routers, 4-axis oftentimes means a C-axis or an aggregate, using an aggregate machine. So this is an aggregate tool that can go in a tool holder, and there's a lock pin right here. It's a little pin that fits in this ring. It fits in the spindle plate, and a lot of people, when they see this image, they can understand better what a C-axis is. This motor is the C-axis, and it rotates that lock pin so that this aggregate tool can face all different angles. You could rotate it at 90 degrees to do it one side of the part, rotate it at another 90 and do the other side of a part. So, or at any angle, you could rotate it 360 degrees. And it can also be rotating while the X, Y, and Z are moving as well, so that you get the full 4-axis motion at the router. So a C-axis is very common on a CNC router. There's other machines that have 4-axis that's not an aggregate. They may have a rotary attachment, like a lathe, for example, and the spindle can go and do its X, Y, and Z while the part is rotating. So some machines out there have like a lathe attachment. That would be a 4-axis operation. But most commonly, it's this aggregate and the lock ring that rotates the aggregate, and it's a programmable angle. So it would be in the program file, it would be something like C 90.2 degrees, and it would rotate, or 95 degrees, or 180 degrees. And this example aggregate can take your vertical motion and turn into a horizontal motion. And you could also imagine putting a saw blade on here, and it would be a saw that could rotate at any angle. And here's some examples of aggregates. A typical operation would be doing lock sets on a door. So you want to machine a mortise lock on the side of a door, or a cylindrical lock on the side, or even the hinge plates on the side of the door. This little guitar body is here. The C-axis is rotating. Oops, sorry about that. Let me go back on screen. The C-axis is rotating as it's moving in X and Y, but it could also move up and down in Z as well. And so this is what's called a molder head aggregate. And you could do straight moldings, but in this case, it's doing a curved molding. So the C is rotating while the X and Y are moving, right? So this is a vertical machining operation. Here's a horizontal machining operation where it's doing some pockets or drill holes on the side of the part, and then that could rotate and affect this side of the part as well. So the C-axis or aggregates can give your machine a very expanded set of capabilities, and many machines can even be retrofitted with the C-axis. If you only have a 3-axis machine now, you may be able to get a retrofit. They also make these aggregates with 4 sides, for example, so that you could do the front, the back, the left, and the right side of a panel, but you couldn't do like one of the odd faces on a stop sign, for example. So you get the C-axis if you need to do some stuff on an odd angle, or if you need to rotate that C-axis simultaneously with the X and Y. And there you have a good example of that with a molder head. And there it is an aggregate, but they also make machines that have a full molder head spindle. So it could have a 20 horsepower molder head on a separate slide there, and that would also be a separate axis. This is a great example for this is an Ontrud machine showing what's called an adjustable angle aggregate, because you can take that angle there and adjust it. So this tool can be adjusted at different angles. And what they're doing there is making the square corner in an MDF door that has a compound profile on it. We can do some of this as a 3-axis move if it didn't have a compound profile. So if it was just a flat edge there, we could do it with a 3-axis move. But in this case, that tool, there you go, see it pivoting around the C-axis, and X and Y can move at the same time. This is a very popular MDF door model, and they use this type of 4-axis machining to do that. That could also be nested. Here they're just showing it one part at a time, but those doors could be nested, and you can do this with a whole bunch of pieces on the table at once. Here's another survey question for you.
All right, so we do have our next question for everyone. Are you experiencing any bottlenecks in any multi-axis programming? Difficulty drawing parts, difficulty in fixturing parts, long cycle times, other, or none, not applicable? All right, everyone can put their answers in. A couple more seconds for everybody, and let's take a look. Okay, so we actually have quite a bit of everyone saying none or not applicable. So let's take a look with Kenny to see what we have next.
All right, it's now we can move into the 5-axis machining. And the real advantage to the 5-axis is eliminating the need to manually reposition the part. So here you could see some different examples of machinery. You still have the X, Y, and Z, but this is what's called a yoke style 5-axis head. And now you have, remember I said there was an adjustable angle on that aggregate? On the last simulation we saw with the Ontrud, that was a fixed angle. Well, on the 5-axis, that can be programmable. So that can move on the A-axis simultaneously with the X, Y, and Z. And then there's the C-axis, which is just like we saw on the aggregates, right? Now, these letters, A, B, C, it's up to the machine manufacturer to label those axes. So they may not always be called A, and they may not always be called C. This is a different type of 5-axis head. It's called a Newtating head. And you still, again, have X, Y, and Z. And then you could see here, they're calling this one a C and a B axis. So they're just slightly different axes designations, but they still make it so that the tip of the tool can really do any kind of motion. And here's another example of a machine showing with different axes on there. Many 5-axis machines, you'll see a very large under bridge clearance here. So you need this big clearance because the parts will typically be fixtured. And so you'll have a large fixture to hold the part up off the table, because the tool may need to do some undercutting. It may need to have to cut underneath the part. And so you're going to want the part to be up off the table high enough so that the tool doesn't hit the table or doesn't hit the fixture. And on this curved door here, you'll see an example where it's a shaper cutter, and it's moving on the curve shape. In this case, it can be X, Y, and Z, and then it's got that tilt angle to it. So here it would be like the B angle to tilt it, or the C simultaneously. But the real advantage to 5-axis machining is the repositioning, right? It means you could take a part and put it on your table on the side, on its side, and do all the side machining. Then you could flip it on the other side and do some more machining. Then you could flip it again and do some more machining. So all of that is manually repositioning the part, doing 3-axis moves on each side. Whereas if you had a 5-axis router, you could position it one time, fixture it properly, and then the machine can go at that and cut from all different angles. It's really all about the number of repositioning moves that makes the 5-axis special. Again, that real tall bridge is so that you can have fixtures and have, you'll find too, you'll have longer tools that are used for 5-axis, because depending on how much relief your part has, how deep you have to go in there, you need a longer tool to do it. So a lot of times you'll see 5-axis machines with very long tools in there so that they can get very deep into the recesses of the part and do the manufacturing that you're needed. Because of that long bridge, 5-axis machines aren't really the best for 3-axis cutting. So if you do a lot of panel processing, the 3-axis machine is better because of that. It's got a shorter bridge and it's more stout. It's more rigid and you get better cuts. So sometimes people think, well, I'll get a 5-axis machine. Even though I do mostly panel processing, that may not be the best choice. If you're only going to do a few 5-axis programs, but mostly doing 3-axis machining, you're better off with the 3-axis machine and maybe find somebody else that has a 5-axis to do your 5-axis work. It's just something to note, that long bridge does give you a penalty in vibration because of how tall that is. So here's some different examples that the CIM-TECH's 5-axis machining module has. Just like with the 2.5-axis, you could do drilling, you could do profile cutting and pocketing and roughing and finishing, and just about any intricate shape can be programmed. You're driving the tip of the tool. So this 5-axis contour is really what it's running here on this part here that's got some angle to it. And the slide that we're showing there is really like it's like a windshield for a motorcycle or a boat. And so when they're vacuum formed, you need the tool to remain perpendicular to that edge and do the trimming operation. Same thing can happen when you take a boat out of the fiberglass mold. You want to trim the edge of the rough fiberglass out of there. So you keep the tool perpendicular to that edge. But you could also do 5-axis pocketing and drilling and different types of machining as well for surfacing and so forth. So you really have quite a few different types of machining operations. Let's think about that drill there. So they're drilling holes at a weird angle on this slide. You could fixture the part so that that weird angle is straight up and down on your router, right? And then just do a straight 2.5-axis move on there. But then you'd have to reposition it to do the outside profile, right? So that's why that 5-axis eliminates all those reposition moves. Many times when you want to do a 5-axis part, you really start by using 2.5-axis machining operation. And that's what you're seeing here first is some pocketing. So it's going to take this solid block and start removing the material in a 2.5-axis mode. So this is just like the regular router sim does now. It pockets in a 2-axis mode, and you'd use, you could use a flat end mill here. And it looks like it's a pretty large end mill so that it can remove a lot of material at one time. So you're going to start with this type of 2.5-axis pocket, then go back with a ball mill and do some finishing operations with the 5-axis mode. So a lot of times you're gonna mix and match toolpath. You're gonna have some 2.5-axis and some 3-axis and some 4 and maybe some 5-axis all inside the same program. It's not just everything with the the 5-axis tool. You could do that, but then that would take a lot longer, right? It would take more time to go and use a small ball mill and carve the whole thing, because this smaller tool only takes a little bit of material at once. And that's what you're seeing next, is the ball mill going through and doing some different operations. And the head is tilting as it's doing that. And so simulation is another thing that becomes very important with 5-axis machining. You're going to want to see how the tool paths affect, and if there's any crashing, tool crashes, it can check for all that. Excuse me. All right, so again, the simulation, you're going to want to see what the paths look like, and this is just going through and finishing with the ball mill in a second here. Go through and finish all the part up. And there's a little simulation of a 3-axis, 4-axis, and 5-axis part. So like the drilling there is just a 2.5-axis operation. The pocketing you saw was 2.5, and it did some surfacing. You're only limited by your imagination with the 5-axis machining. And so on a part like this, we could tilt the part so that this faces up and do a 3-axis move, or 2.5-axis to do that pocketing, and tilt the part so it does this. But if we leave it on a 5-axis machine, we could do those drill operations, change tools and do pocketing, change tools and do the pocketing on the side and on the top, and we could do it all without having to reposition the part. That 5-axis head can go all around this part and do all the required machining without having to reposition the part on the table. And it's just showing some different examples there. Again, here's a shaper tool that's going to be on its side as it does this operation, and another tool is going to be on this angle, and this one's going to be on this angle. So you can see the different operations that could happen on there. Only limited by your imagination. Here's one showing a entry door, and this will have a machining on the side. So there's some hinge plates being machined on the side. Now they do sell a tool with like a small 4-degree angle on there, so that you could put the hinge machining right there on the side. But doing that little lock set, you want to go into the side of the part. This one's a little too big to position this so that this is facing up, right, on the table. So really an aggregate is what you need to do that horizontal machining there. And you could do different size tools and things like that to do small holes and big holes. And there's the hinge plate. That could be done with an aggregate, but it could also be done with a vertical tool. They do sell a tool that does that vertically as well. All right, here's another example. Now this is where, when we talk about woodworking and 5-axis machining, you're really going to think about complex furniture parts. You know, I talked about, what do you call it? I talked about like trimming a windshield, a motorcycle windshield. Sure, you could do that, but if you're doing woodworking, it's going to really be, the majority of things are going to be complicated furniture parts. And that's going to be this stuff like a Queen Anne leg, right? And that's what it's doing here. It's going to go back and forth, and it's going to mold that Queen Anne leg with a ball mill, and then go back and do some 5-axis machining to carve the whole thing out. I can run through this and give you a little more visualization. So we really had to remove a ton of material there, and now there's the ball mill going back and forth. And that is the 5-axis type of tool paths. And then the next operations, you could see it going and carving from one angle and the next. And that's it. So it's complicated. 5-axis furniture parts, very common. You can see the carving on the side there. So that step over applies here as well. And so the closer together you have your spacing, the finer that surface finish is. And the less sanding you have. So no matter what, you're going to have sanding because the ball mill is going to leave little bumps on the part, right? I'm going to put a little ball on the end there. So you can think of things like a newel post or, you know, any kind of furniture where you have complicated machining. That's where the 5-axis can really shine. And they produce that part in just a couple different machining operations. Now, not when you say 5-axis, your machine may have more than 5-axis. A surprising feature here is a machine like this one that has 4 spindles with programmable head spacing. So when you come across a machine like this, the spacing, the axes to space each head out, it's another axis. So when you got a machine that has this complicated multiple head programmable spacing, oftentimes the machine vendor has to go to more sophisticated control. They have to go up to the next level controller that could support 6, 7, 8 axes at once. So you still have your X, Y, and Z, but now you'll have your space between the head, 1, 2, 3, so all of those are all programmable. And these spindles, each one of those might have its own C axis as well. It may be able to take and rotate the tool about those axes. Today's machines, there's really no limit on the complexity of them. So this one has 4 spindles with 4 tool changers, but that doesn't mean they don't make it with 6 or 7, 8 spindles, as many as you want. And that does add to the complexity of the post processor to program that, because now you got to be able to tell it what the spindle spacing is. So there's an example where it could be more than 5-axis and not have that 5-axis head, that rotating head and so forth. All right, let's take a look at how we can leverage the existing router sim tools to use the new 5-axis machining operations as well. Inside the CIM-TECH software, it's called Router Sim as the core product, and there's something called machining knowledges. So the 1/2-inch router bit doing 1,000 inches a minute in a counterclockwise cut direction at so many inches per minute. All those settings are saved as what's called machining knowledges, and you could use those over and over. And then there's integration with AutoCAD. So I can just use AutoCAD's move and copy and rotate and erase and zoom in and zoom out or drag and drop parts from other jobs. Those very powerful feature right there. And anybody that uses CAD/CAM software, you're going to know that you have the same set of commands that you use all the time, like move and copy and rotate, erase, zoom in and zoom out. We use the AutoCAD version of those, which makes it a little easier to learn and use. Now, when it comes to 5-axis as well as 3, you could have multiple machine output. That means you could run your program on an on-screwed today, but you also want to have the program available to run on your Biesi or your Northwood or your Homag or your Como or your, any one number of different machine manufacturers. They all take slightly different programs. So you want to be able to take this same sheet, for example, and output it so that it's available to run on any of your machines that you have. So over the years, you may have gotten 3 or 4 different machine vendors, 3 different manufacturers. You want to be able to make that program run on any router. We can output to multiple machines, and they can have different post-processor capabilities. Now, when we say capabilities, means some machines might have an integrated material handling, so they can go and grab the piece of material from a stack of material. It can print labels on the part. It can unload the part. It could have an inkjet printer head on there. So the post processor is involved with a lot of these different features, like that multiple spindle spacing, right? The programmable head spacing. The post has to output that. Putting out the code to grab the sheet of material from a certain location. That's in the NC code. That's a post processor handle. Making the labels and things like this. Those are all part of the post processing capabilities and output to different machines. Now you can nest multi-axis parts, and the best example of that would be that MDF door we saw cutting with the 4-axis adjustable angle aggregate. You can put multiple doors there and do that. You probably wouldn't nest 5-axis parts or even 3-axis because they take so long that you'd want to just cut one and then take it off the table and load another one and do another one. You wouldn't want to have to stop the machine to take parts off. But you could do 4-axis parts on there too. If you're going to do aggregate parts to nest, the parts have to have a spacing large enough so that the aggregate can get between parts. There's also a feature in RouterSim called the Do It Editor. And so, like I said, these knowledges have the tool, the feed rate, the spindle speed, the cut direction, all those parameters. You can associate that a specific layer in your CAD to one of those specific machining knowledges. If it's on this layer, use this knowledge. This layer uses this knowledge. And then you can see what layers are in there and which drawings have what on them. It's a very powerful way to see all your different layers and how and what type of machining is applied to those. So let's look at, in conclusion here, how the CIM-TECH software can integrate all these different types of machining operations, whether it's just 2.5-axis pocketing and drilling and panels processing, to 3D carving, all the way through aggregate machining with a molder head or a saw aggregate, or just drilling and routing on the side of a part, like the door, entry door, operations for hinges and lock sets, all the way through to complex 5-axis machining that's now available inside of the RouterSim. We call it the 5-axis machining module. And you get them all inside of one product, and all that product works inside of AutoCAD. So you get an integrated and automated CAD/CAM program that can handle all those multiple axes, including the ones we talked about, like that multiple head spacing. And you can do all that with the CIM-TECH software. And we really appreciate you taking a look at this. I'm available for demonstrations personally as well. And we have some time now. We can do some questions and answers.
All right, thank you, Kenny. And with everything that you went over today, it's no wonder that we definitely have quite a few questions that came in. So we can take a look at some of those here. When we have here, are there any limitations to what you can program in 5-axis?
You know, I like to say you're only limited by your imagination, but you're going to be limited to what you can draw or model as well. And so if it comes to designing a very ornate chair leg, for example, you may need to get an existing product and take it to a rapid prototype shop and have them scan it for you to make the 3D model or a 3D surface. So you might not be able to draw, you know, a complex lion claw, you know, on a part, but you could definitely find one and get it scanned in 3D, and then you'd be able to program it. So drawing it might be tricky, but scanning it is a solution that can apply for a lot of people as well.
Gotcha. Okay, so it's really going to come down to what you can draft and get modeled up. Okay. Another one we had that came in, will this work with older versions of RouterSim?
Oh, that's a great question. So the 2, 3, and 4-axis machining can work with any version of RouterSim, but the 5-axis machining module needs our latest technology in RouterSim 2022.
Gotcha. Okay, so thanks for clearing that up. I know that was pretty similar to what we've seen in the list of questions here. Another one that we got, can your multi-axis solution work with models from any 3D modeling software?
I would say yes to that, because when you go into AutoCAD, you could type in the word import to command, and you'll see a list of all different sources there. So in the old days, surfaces were imported as IGES files, and you can import IGES and they come in as a surface. More people are doing 3D modeling, and you can import those as a step file. That's kind of like the IGES of solid models. Plus, you've got CATIA and Rhino and Pro Engineer or Creo files in there. STL, there's a whole host of different file formats that can be imported directly into AutoCAD, and then we can cut those direct. So you got just a ton of different interactive interusability there from other products. Any kind of source, yes.
Okay, great. So it's good to know that there's a lot of flexibility in terms of how we get to those models. Okay, so here was another one. Do you need special tools for 5-axis? Now this one, they left it kind of open-ended, Kenny, so I think it's probably best if we address potential special hardware tools or perhaps any special software tools. So do you mind covering kind of both ends of that question?
Sure. Well, for software, you need the new router sim 5-axis machining module and a post processor for your specific machine. So that an Onsrud 5-axis is going to be different than a Northwood, than a Como, than a Homag, than a Biesi. They're all going to be a little bit different. So the post processor will output for that machine specific requirements. And then as far as tools go, we talked a little bit about it. You need really longer set of tools. Now you could put any shaper cutter in the 5-axis spindle. It's got a regular tool holder. Many of them use the same tool holders as the 3-axis machine with either a BT30 or BT40 or HSK type of tool holder. So the machine will accept just about any kind of tool. But when it comes to the like that chair leg, longer ball mills and longer end mills are needed to get into the recesses of the product that you're trying to cut. So tools, you'll notice, will be a little bit longer than they were for 3-axis machining.
Okay, that definitely makes sense. So and hopefully I think that that covered both ends of that question there. This one, I think they just want a little more in depth because I think you mentioned it in the presentation, but can I nest 5-axis parts?
Can you? Yes. Should you? No. Right? Because they're going to need a fixture. The 5-axis parts are almost always going to need something to build them up off the table so that the head could tilt down and get in undercut areas. It depends on the part, of course. Plus the amount of time it takes. If you had 3, 4, 5, 10 parts on the table at once, but when it finishes one, by the time it finishes the 10th one, could be hours later. So you couldn't really remove the first one until the last one is finished. You could nest the 4-axis parts like that MDF door with the square corners. That would be a good example for nesting a multi-axis part. But the 5-axis, probably not. You probably wouldn't do that because you need a fixture on there to hold the part in the position.
Gotcha. Okay. And it looks like we have time for one more. Looks like, what are the example parts that require 5-axis machining?
Okay, there's your imagination again, right? So what we see typically would be, if you just Google search 5-axis machining, you'll right away see a turbine blade, right? So a turbo or a turbine, that's one of the most common things that they do with 5-axis. That has nothing to do with woodworking. You're not going to make a wooden turbine blade, but the Queen Anne leg, a complex furniture parts with intricate carvings. So there's your furniture products would be the most common woodworking 5-axis. For other things you would use on a CNC router would be 5-axis trimming operations like the windshield or boat parts from a boat or an RV, for example, where you may need to do um, a trimming operation on a compound edge. So I would say it's mostly for woodworking. It's going to be complex furniture like the lion claw or a Queen Anne leg.
Okay, I think that tends to clear things up a bit and give us some idea there. And it looks like, guys, anyone that has inputted any other questions for us, we are going to have to reach out to you guys individually to get to those. That was the last question that we do have time to answer today. So thank you, Kenny, and we're going to go ahead and hand this back out to Harry.
Great. Thanks, Kenny and Giovanni, and thank you, CIM-TECH, for the tremendous job you did in breaking down what we need to know about multi-axis machining. And for those of you that weren't able to get your questions answered, I know the CIM-TECH team will certainly answer your questions offline. And thanks for participating in the polling. We got some great participation there, and we really appreciate you showing up today. Again, a reminder that this webinar has been recorded and the recording will be available within the next 24 hours. With that, I'll say so long, everybody, and we'll see you again.
Thank you all.
Thanks, everybody. Have a great day.